Hello, good morning, students. I am Dr. Sunita Tandon from RR College, Alwar. Today I am going to deliver the lecture number 10, which heading Enzymes and Inhibitors. In the last lecture 9, we have studied the kinetic of BZ reactions, and now we will study enzyme and inhibitors. First of all, we see into enzymes. Enzymes you have studied in the earlier classes, that is in third year or second year in physical chemistry. It is something somewhat advanced, but inhibitor and enzymes are the chapter is same. We will study first about enzymes. Enzymes may be defined as biocatalysts synthesized by living cells. These are proteinaceous in nature. Most of the enzymes are protein in nature. They are found in living organisms. Colloidal and thermolabile in character. Colloidal means when we add something to it, they collide. If we add some water, some temperature changes there, they collide and lose their reactivity. And thermolabile means they are affected by the temperature. Secondly, they are specific in their action. They are specific in action means they are reaction specific means an enzyme can accelerate or inhibit one type of reaction, and maybe it not working with reactant B. They are specific. We cannot use single enzyme for many kind of reactions. They are very specific in their action. Next, enzymes are biocatalysts. As we have studied autocatalysis, catalysis, and their action, their kinetics. Similarly, enzymes are biocatalysts. It means it is found in living organisms. The catalyst of life. They are called as catalyst of life. Living organism में पाए जाते हैं. A catalyst is defined as a substance that increases the velocity of or rate of a reaction without itself undergoing any change in overall process. What is enzyme? It is a catalyst and is defined as substance that increases or the velocity of rate of a reaction, है ना, without its undergoing any change in overall process. The reaction product will be same, it will be achieved earlier, and there is no change in overall process. Enzymes have extraordinary catalytic power. They accelerate specific chemical reactions without formation of byproducts, and they function in dilute aqueous solutions. Enzymes are extraordinary catalytic agents. They have extraordinary power. They accelerate specific chemical reactions without formation of byproducts. This is important. When there is byproduct formation is there, the main reaction remains unimportant, or main product will decrease in quantity. So they don't have they react without formation of byproduct. This is very important. Enzymes shows all properties of proteins. The properties which are shown by proteins, they are all shown by enzymes. Enzyme has its own 3-degree structure. It means they are 3-dimensional structure. 3D structure means they can figure in spatial arrangement. There is change in spatial arrangement. It is not a one single order or single plane structure. Specific conformation, which is very essential for the catalytic activity. That is why they have 3-degree structure. Enzymes are highly specific in their action. The 3 type of enzyme specificities are there. They are because they are specific in their action, and their specificity can be of 3 types. First has stereo specificity. It is related to its 3-degree structure. Other is reaction specific. They catalyze a particular kind of reactions and not all. And third is substrate specificity. It means they work with specific substrates, not with all substrates. Now we will study today one enzyme, 2 substrate systems. 2 type of reaction models are reported for the kinetics of one enzyme and 2 substrate systems. One enzyme and 2 substrates. ठीक है. The one enzyme and two substrate system. In this case, case of reaction model are reported for the kinetics of enzyme and two substrate system. This is further we can classify it into first as sequential, ठीक है, and second is non-sequential. First is sequential model. There are two models, sequential model and non-sequential model. First is sequential model. These are of further two types. Sequential model is further of two types. First is ordered model and B is random ordered model. As the name suggests, first is ordered model and second is random ordered model. These models, in a simple way, are explained on the basis of Cleland rule. Cleland rule defines these models. Cleland model for sequential mechanisms. We are studying first type of mechanisms. This is Cleland's model for sequential mechanism. For ordered mechanism, the Cleland model is represented by the following diagrams, in which horizontal line is for progress of the reaction. You will see a diagram on the right side of the next page or on next page, in which we see that in ordered model of Cleland, it is represented by a diagram with horizontal line which shows the progress of the reaction, and a vertical line are for ordered additions of the substrate to the enzyme and ordered release of product in the same manner. Horizontal line is for process of the reaction, progress of the reaction, and vertical lines in the enzymes, lines are for the ordered release of product and reactant, addition of reactant and release of product in the same manner. In this ternary EAB, complex is formed in an ordered manner. First reaction is E जो है, it reacts with A and form EA. This is a complex. In the second step, EA collide with substrate B. A and B are substrates, ठीक है, with B to form EAB. ठीक है. E is here enzyme, A and B are substrates. Now see the diagram. In this diagram, the horizontal line represents enzymes, ठीक है, and complex, and the vertical line shows addition of reactant, and vertical line also show product of reaction. There is a slight turn in the reaction in the tip of the horizontal vertical line. Just see where addition of A and B takes place and where products are formed, it is upwards. P in this case, product P is product of A and Q is product of V. Just see the line. The release of product should be in the same manner in which these are added. Okay, just see this line. Here it is enzyme. Here is again enzyme in the top, extreme lefts and rights, and the complex EA which is formed is written on this horizontal line. This is complex EA. In this complex EA, through a vertical line, addition of A take place and a complex EA is formed. Similarly, in a vertical line, addition of B take place and a product EAB or EPQ is formed. Why it is called EPQ, we will see later. Now, EQ, out of this EPQ, product P is released on this horizontal line. A vertical line P is released, therefore E and Q are remain. In the next step, Q is released and enzyme is regenerated. A and B are added and P and Q are removed in an ordered manner. The release of product should be in the same manner in which they are added. Important conditions: both of substrates should be added at the same time. A and B should be added at the same time. The second है ternary complex must be formed, and the ternary complex is formed. Second type of system is random ordered system. Enzymes should we have seen two type of additions, ordered model, sequential model में we have two type, ordered model and random model. Random ordered model, ordered model we have studied Gilliland's order, and now we will study the random ordered model. Enzyme should also form ternary complex in this case, and also but release of the product may occur in a random order. अब ज़रूरी नहीं है कि पहले A ऐड हो फिर B ऐड हो फिर वापस से P निकले और Q निकले. अब there is random addition. E line, E to E line suggests the horizontal line. Product A is added first and is then, sorry, for in this case product A is added first and then B. ठीक है. Then they form EAQ or EPQ. Then from this randomly added A and B are also there. They are first added B and then added A. So EAB or EPQ complexes formed. In the random release, from EAB or EPQ, first P is released, then Q is released. And in a second reaction, first Q is released and then P is released. Non-sequential mechanism. In this case, A is added first to E. First, A is added to E and complex EA or EP is formed. E changes to epsilon. E changes to epsilon or E form. मतलब it changes its form and it changes to the product and then it changes to the product. Two important observations for non-sequential mechanism are: first, one substrate should add to the enzyme and its product is released. One substrate should add to the enzyme and its product is released. First, one is added and its product is released. Secondly, the enzyme form should change from E to epsilon. Structure or form of enzyme change. Thus, a new form of the enzyme combines with another substrate and then reactant give a product which with the release of enzyme in the original form. यहाँ पर वैसा सिंपल नहीं है. यहाँ पर पहले क्या होगा कि एंजाइम ई जो है वो एप्सिलॉन फॉर्म में चेंज होगा एंड जो नई फॉर्म बनी है एंजाइम की एप्सिलॉन वो कंबाइन करेगी सबस्ट्रेट से, दूसरे सबस्ट्रेट से और रिएक्टेंट से और फिर प्रोडक्ट देगी और ये प्रोडक्ट रिलीज होगा विच ऑफ एंजाइम इन द ओरिजिनल फॉर्म. जो रिलीज हो जाएगा प्रोडक्ट एंजाइम अपने ओरिजिनल फॉर्म में आ जाएगा एप्सिलॉन फॉर्म से. इट इज़ इम्पॉर्टेंट to note that both the substrate A and B or both the products P and Q must not remain with the enzyme at any moment of the reaction. This mechanism is also called as ping pong mechanism. ठीक है, फर्स्ट वाला मैकेनिज्म कहलाता था, कीलैंड्स मॉडल पढ़ा था हमने, एंड दिस इज नोन एज पिंग पोंग मैकेनिज्म. Students, we have studied this. Now we will study the kinetics of sequential mechanism in the next chapter. Thank you.